In this video, we're going to learn how to estimate the foundation wall that goes on top of the foundation. Previously, we have worked with the foundation drawing S1, where we have a foundation called GB1 on top of a number of auger cast piles. So I have created a small model that shows the foundation on top of these piles. That's the work that we have done before. Today, what we're going to do is we're going to see that there is a foundation wall made out of concrete masonry units that goes into this on top of the foundation, and it's limited by the location of the different columns. So let's look at the drawings. The drawing that we're going to work today is drawing S2. This one shows the foundation ground floor framing plan. So we see that we have different walls. There are different notations for the reinforcement and the name of the walls. There is also naming for the different columns. We can see the legend. It says the this type of dashed lines arrangement is a 8-inch CMU wall below. This one is a 8-inch CMU wall reinforced with a 9-gauge ladder type horizontal joint. And this kind of a rectangle shaded is a concrete column. See schedule on sheet S6. So we see that there is a masonry reinforced masonry schedule. We have the different marks for the different type of walls, and what it says is mark 8M R548 has number 5 bars spaced at 48 inches. 8MR 524 has number 5 bars spaced at 24 inches. And then we see here that we need to provide one number 5 at each side of the openings, corners, and wall interceptions. So what we're going to do now is we're going to measure this foundation wall that goes on top of the foundation. This represented over here by those concrete blocks. What we should do is we should start with a new condition. So this new condition, we could be specific with the name of the foundation type, but I'm just going to create a linear condition that's going to be called foundation wall. Just because I am going to consider that there is only one type of foundation wall, because I only have one source of cost for it, and it's going to be an average a little bit more expensive than the regular one because it considers that everything has reinforcement, which is not exactly the case here, but in estimating, sometimes we have to go with the best estimate or our best judgment. So I'm going to set up the thickness to 8 inches because these are 8-inch concrete masonry units. And then I'm going to start by measuring this wall from the outer edge to the outer edge. Then again, I'm going to proceed by estimating the from the inner edge to the inner edge here, so very carefully to not overlap the corners and also not to include the columns in the takeoff because the columns are concrete columns. So I am going to continue my takeoff by following the contour of these foundation walls. Notice that this type of foundation wall, this type of marking is also a foundation wall. So I need to go ahead and estimate that. I will start at the edge of this column and I'll move upwards to the edge of this column. Oops, it's a little sensitive today. And then from the edge of the column again to the other edge of this wall. I'm going to stop here, but you should continue to estimate the foundation wall all the way to the end. You should continue to estimate the foundation wall all around the perimeter of this building and the inside on top of this foundation. For the purpose of our estimate, we're going to assume that all of that foundation wall is going to have the same height. So the question is, okay, what would be the height of that foundation wall? Let's look at drawing S4, which has the detail that we were looking at before with the piles and the ground GB grade beam. So if we zoom in here, we're going to notice a couple of things. There's 3 feet from the finished floor to the top of the foundation. The edge of the slab, the outer edge, has a 1 feet dimension. So we can safely say that from the bottom of that base for the slab to the top of the foundation are going to be 2 feet. So that's going to be the height of our foundation wall. We are going to consider that the entire foundation is made out of it's 2 feet high, and it runs on top of the entire foundation. Now we're going to proceed to do the cost estimate. From on-screen takeoff, we have made some estimate from drawing S. Now let's proceed with the cost estimate. From in on-screen takeoff, we have made a takeoff of this foundation wall. We call it foundation wall, and if we go to the takeoff tab, we see that we have the foundation wall. So far I have measured 76 linear feet of this foundation wall. So I'm gonna go and open my Excel file under the OST tab. This is where I am going to import the information from on-screen takeoff. So I'm gonna go ahead and take this foundation wall by clicking on the rightmost cell and drag the mouse up to the number for that foundation, for that condition. Notice that only one line is highlighted in blue, so I am going to only be copying one line. I right click on the condition, I click copy, and now I go to Excel and paste that information on Excel. So now I have the quantity of 76 linear feet foundation wall. So I have estimated the quantity. Now I need to estimate the cost. For the cost, I'm going to go into our course estimate, our course website. Under cost reference, there is a masonry cost data that has the information that I need. So in this masonry cost data, when you open it, you will see that there are several unit masonry assemblies. So we're going to just scroll down a little bit, and we see that they include also the crews. Alright, so we are going to look for concrete block foundation wall. Concrete block foundation wall. We're going to use a reinforced number 4 vertical at 48 inches, hollow 8 by 16 block 4-inch thick. Solid 8 by 16 block 6-inch thick. Well, I am going to just select the hollow 8-inch by 16 block 4-inch thick. This has a crew of D8. The daily output is 455. The hours is 0.88. But notice that the unit of measure is square feet. So all of these unit numbers are made in square feet. That means the daily output is 455 square feet of foundation wall per day, and each square feet is going to take 0.088 work hours. The material cost is 162, the labor cost is 281, and in this case it doesn't seem to be any equipment cost. So I'm going to start by copying this information in the Excel file. I am going to open my Excel file. Now I'm going to go into Division 4 Masonry, and I'm going to type here description foundation wall. Okay, so the code for the foundation wall is the code that RS means will have. So in this case is 04810 for unit masonry assemblies, followed by 186, followed by 1100. So I'm going to type that in 04810. Sometimes it's easier if we reduce the size of the Excel file so we can see the numbers of the cost reference window sitting behind it. So it's 04810, 186, and then no, I'm sorry, 011. That doesn't read too well. I guess this here would be 011, and then 1100. That's the code for the foundation wall. We have the information about the crew, and we may want then to enter that. Let me scroll this a little bit up so we can see exactly how enter the data. The crew is going to be crew the 8th. Daily output is then 455. Labor hour is 0.088, and the unit of measure is square feet. Now, again, these numbers, I don't see the decimal points, but I can select them and use the comma delimiter so I can see the decimals. And then I'm going to enter the material cost 1.62 and the labor cost 2.81. Sorry, 2.81. So now we have the materials and labor cost in entered, but the problem that we're facing right now is that the unit of measure is in square feet, and what I have done in on-screen takeoff is I have measured the linear feet from the foundation drawing. So we know that the height of these walls are going to be 2 feet. So I'm going to create here an area for the foundation wall calculation. So I'm going to have a linear measure from OST. This is going to be equal to, I go to OST and I get the linear feet, and then I'm going to type in here height of foundation wall. This is going to be 2 feet, so the area of the foundation wall is going to be equal to 76 times 2, which is 152 square feet. Okay, So now the RSM table, I can go to division 4 masonry, and now I can maximize this, and the quantity of work is going to be equal to the calculation area that I just found. So if I wish, I can add a let's say a 5% waste factor. So we have a total quantity of 159.60, which is the quantity of work that I measure, plus 5% multiplied by the unit cost on labor and material, and that gives me the total. This is extremely good because if I already have now a setup in which I can calculate the area of the wall based on my on-screen takeoff, and that automatically calculates the cost for the masonry. So if I go to on-screen takeoff and then I continue my foundation wall takeoff, I can, of course, I'm going to increase the linear feet that I have taken off with on-screen takeoff. But now it's very simple for me to go to the takeoff tab, select again the foundation wall, copy that information, and paste it on the OST tab in Excel. So now notice that the 76 linear feet that I have before are now converted to 144, and automatically that number is entered in the calculations to calculate the updated area, and that updated area is used to calculate the cost of the foundation wall. That is a procedure that you should follow. You should do a small takeoff for each one of the divisions that you are doing, and then create the framework to import the entire takeoff.